All right, today I'm going to talk about significant figures, our favorite topic. All right, so we've talked about measurements and we talked about the accuracy of our measuring devices. The more divisions I have on my measuring device, the more accurate the measurement. And so now what we need to talk about are something called significant figures that only matter in math classes like chemistry and physics, where we talk about measurements versus a regular math class where you're not taking measurements. Because here's the thing, I cannot report my answer more accurate than my least accurate measuring device. So that means I can't over-report the accuracy of my answer in calculations. So I want to look at significant figures. So the definition of them are meaningful digits in the measurement. So how do I know how many significant figures? So there's a rule. So every number that is not a zero are significant. So all non-zero digits. And then this rule I like to call the sandwich rule. So zeros that are between two non-zero numbers, so two digits 1 through 9, are going to be significant. Because I can't have significant, not significant, significant, hence the sandwich rule. Zeros at the end of the number and also to the right of a decimal point are significant. So those are ending zeros at the end of a decimal. Okay, those are significant. It's a conditional statement. Both of those have to be true. But zeros at the end of a number and they don't have a decimal point are not significant unless I show you the little shortcut. I'm going to give examples of all of these. And then counting numbers we don't really need to worry about those because they're not going to be significant. But we rarely will count things in chemistry because counting numbers, it's not an actual measurement. All right. Also the rules for calculations. For multiplying and dividing, I round my answer to the fewest number of sig figs in my calculation. So if I take a look at my example here, 3.99 would have 3 sig figs, while a 4.2 has 2 sig figs. So I must round my answer to 2 digits. So I rounded it to 17 centimeters squared. Now, adding and subtracting, I only need to look to the decimal place because remember, we said in our measurement section, the more decimal points, the more accurate. So that also is the opposite. The less amount of decimal points, the least accurate. So when I'm adding and subtracting, all I need to do are look at my decimal points to tell me which one is the least accurate. So in my example here, this measuring device was able to go to 3 decimal points, while this one was only able to go to 2. So this one is the least accurate out of our 2 measurements. So I must report my answer to the least accurate, which was 2 decimal places. So I can just cut off, or I can just check it. I put there, does that 0 round the 7? No, so I can just cut it off. And my answer will be 11.27 centimeters. So let's take a look at some of these where we counted, and we'll note the ones with zeros. So 652 has 3 significant figures because they're all non-zero digits. But 320 only has 2 significant figures because this 0 at the end is just a placeholder. But number 3, 12.650, that 0 was an estimate because it's at the end of a decimal. It's to the right and at the end. So my measuring device was able to go to 3 decimal places and it was exactly on that 0.05 line. And then number 4, this leading 0 is also going to just be a placeholder. So it's not going to be significant. All right, it's just a placeholder there because my mass was less than 1. So it's just a little placeholder there. So the 5 is significant, the 2 is significant. Those zeros are sandwiched, so those are both significant. The 1 is significant, and then this 0 at the end. So I had a very, very accurate measuring device to get to 6 decimal places down there. Anything in scientific notation is always going to be significant. I only care about the M value over here. So all of those digits are significant. So that's our hint. I'll show you. If I need to make something significant, I can automatically put it into scientific notation. Or if we skip down to number 7, I can add a decimal at the end, and that makes all of those digits significant. So then it's 5. Okay. So this practice sheet is in your folder, and then same with this answer key. But let's scroll down or flip to the back side where I have some examples. These ones were rounding. So I needed to round to my 2 significant digits. So I count from the left, and then I always need to check. I write this little line, and then I always need to check to the right of that line to see if those numbers are going to round the numbers on the left. A 4 will not round, right? Remember, 0, 1, 2, 3, 4, you do not round. But if it's a 5, 6, 7, 8, or 9, you will round up. So for number 2, that 6 will round that 5 up, and then I turn the rest of the digits into zeros for both the number 1 and number 2, a number larger than 1. But if I have a decimal like 3 and 4, I can just check to see if it rounds and then cut them off. Okay, you don't need to turn them into zeros. You just cut them off. Now this one over here, number 4, I needed 3 significant figures, but once I round that, it would be 700,000. And so what I did was put it into scientific notation because I needed 2 of the zeros to be significant. All right, so scientific notation is our other way that we can put something, that we can create significant zeros, really. All right, so again, these practice problems and this answer key are in the chapter folder. Let me know if you have questions on significant figures.